Welcome back to TAFE, New South Wales River and Air Institute. What we're going to have a look at now is the ESR of a capacitor, particularly the ESR of an electrolytic capacitor. ESR being the equivalent series resistance. All capacitors, the way they're constructed, and here we've got a printed circuit board with a number of different capacitors on it. The way they're constructed with the plates and leads, they've got a certain amount of resistance. What happens over a period of time, the electrolytic capacitors, which are a liquid-filled component, they dry out. And as they dry out, it's like putting a cup of water inside a board, and that cup of water will evaporate over a period of time. Same thing happens with capacitors. That liquid dries out over a period of time and changes its capacitance value, which adds effective or equivalent series resistance to the circuit. So this particular device here, called the ESR low ohms meter, gives us the capacity or the ability to measure a capacitor while it's in circuit, thereby saving on some time, increasing efficiency, and it's a non-invasive way of troubleshooting a circuit without having to pull this capacitor out and understand when you're pulling it out, you're heating up, you're changing the value. You can go in and basically measure the capacitor while it's in circuit and see what's supposed to, see whether it's faulty or not. Now, if we can screen grab into this chart here, there's a bit of a cross-section chart, and as we can see, click on 22 mic. So if it's a 22 mic capacitor, and say it's a 63 volt, so 22 mic, 63 volt, this ESR meter should read around 1.5, worst case scenario. So we're looking at a value less than 1.5 on the reading, and so on and so forth. So this one here is a 220 mic, so I'm going to measure this one here. Screen grab 220 mic, 250 volts. So 220 mic, 250 volts. So 220 mic, 250 volt, 0.5 of an ohm, worst case. We turn the meter on, we grab the probes, we short them together, zero it out, turn the PCB over. Because it's an AC signal coming from this, it doesn't matter which way the probes are connected, and we measure 0.17. It's supposed to be less than 0.5, so we've got a winner. And effectively, you go around and measure your capacitors, ensuring that they're discharged. Obviously, you're not going to measure the capacitors on the board if they're charged up or power's still on the printed circuit board. Or you can do it on the front side of the board, printed circuit board. We've got another smaller cap here, and this one here's a 10 mic 100 volt. So 10 mic 100 volt. Measures 0.6, so if I go 10 mic 100 volt, cross section 10 mic 100 volt, 3 ohms, so pretty good. Obviously a lot of the time with capacitors you can see that they're starting to dry out, they look a bit deformed. What I've got here is a couple of faulty ones. Now obviously we've gone to the effort of pulling these out of circuit, so we could measure these with a capacitance meter on LCR bridge, just to prove the fact. This one here is a 220 mic 400 volt, 220 mic or 400 volt, it's going to be obviously 0.5. If I measure that one there, we can see it's open circuit. No short, no reading on the reading at all. Back to the capacitor. Gonski. Here's a smaller one here. This particular one here is a 1 mic. 1 mic. Looks like a 400 volt. No, 1 mic 160 volt. 1 mic 160 volt. So 20 ohms, thereabouts. I'll go down here. If you look at the meter, I'll try to get the probe on this thing here. And it's measuring 28 ohms. So it's higher than the 20 ohms, so therefore we suspect that's going to be faulty. And the last cap here is 100 mic 25 volt. So 100 mic 25 volt is going to be 0.32. Once again, just stop that cap rolling around. You can see it's going to be much easier while it's in circuit because it wouldn't be rolling around like this. And 48 ohms, so fairly significant. And all these caps, I'll just hold that there for you. They look quite normal, which is what I said before. Normally you visually see that the cap will start to dry, but these caps actually look quite normal. They're not dried out, they're not deformed, the packaging hasn't shrunk on the cap, and yet they're faulty. They measure faulty. And that looks quite acceptable.
visually speaking, but the fact is it's faulty. And this cap here, I know there is a slight bulge in it. But once again, it's not shrunk. Looks like it's quite a normal cap. Fact is, she's faulty. And these are the type of caps we would have had already on the printed circuit board. You would have been able to measure them, say bang, bang, bang. A bit high, take them out, replace, and away you go. And that ends the ESR Prac.